In this video, I'm going to go into a little more depth on the method of completing the square and how we can use that method to rearrange our quadratic equation into an equation of this form here. This form has a lot of advantages because we can see the operations that are done to the parent function, the parent quadratic function, y is equal to x squared. So the operations that are done is we have a horizontal. So if I go from this function here to this form, it has the same shape. It's just been translated left and right or up and down, and it's been magnified by a factor of a. So we can see that h is going to be our horizontal translation, either to the left or to the right, depending on the value. And k is going to be our vertical translation, either up or down, depending on its value. And then a is like the magnification, either we're stretching it or we're compressing the graph, or this function. And so just to get right into it, oh, one more thing, if I'm this x squared has a vertex at 0, 0. So if I'm translating the parent function h number of units and then k number of units, then I know that the new vertex is going to be at hk. So I'll just write that vertex at hk. So let's just do some examples first. I'll have this quadratic equation y is equal to x squared minus 2x minus 7. And I want to put this into that form there so I can find where the vertex is. Well, I'll just look at these first two terms and I'll complete the square in the first two terms. In other words, I need to have x squared minus 2x, and then using the completing the square method, I'll need plus 1 there. But in order to keep this second line equal with the first line, I'll need to subtract 8, since 1 minus 8 is negative 7. I just put a parentheses around that. And I have x minus 1 squared minus 8. So now it's in the same form as this. So we want to pay attention to the translations here. This has a horizontal translation of 1 and then a vertical translation of negative 8. So I know the vertex is going to be at 1, negative 8. So how that's going to look is it's going to look, it's going to look like this. If this is 1, negative 8, and then if I wanted to solve for the zeros of this parabola, I just have to set y is equal to 0 and solve for x. I'm not going to do that because I want to keep my videos kind of short, so I'm just going to do a quick overview of several of these that we can rearrange like that. So I have another one, y is equal to 1/2 x squared plus 4x plus 8. And I just want to figure out where the vertex is, and maybe the magnification factor a. So I just look at the first two terms. I'm going to factor out a 1/2, and that's x squared plus 8x on the inside plus 8. So if I were to distribute the 1/2, I would get the 1/2 x squared plus 4x. And then I'm going to complete the square on this inside part there. So it's x squared plus 8x. 8 divided by 2 is 4, squared is 16. But since I added 16 here on the inside, on the outside of these parentheses, I'm going to have to add 8. I'm sorry, subtract 8. So actually, I just have 8 minus 8. Since I have 16 times 1/2 would be like adding 8, I'll have to subtract 8 from there. So this is actually going to end up being 1/2 times x plus 4 squared, and then the 8 minus 8 disappears. So from here, I actually could have just left 8 inside, because I could have just factored out the 1/2 and I would have had 16 there already. So I don't know if you can see how I could have just left the 8 there and just factored out the 1/2. But okay, so mainly I want to pay attention. There's not going to be a vertical translation. It's just going to have a horizontal translation to the left 4, and then it's going to have a compression of 1/2. So the new vertex is going to be at -4, 0. I'm going to do a couple more examples. I'll do this one first. Y is equal to 9 minus x squared. So for this one, all we're going to have to do is factor out a -1 here. So I can just say this, well, that's negative x squared plus 9. And now it's in that form. So h is 0. I just have a translation up 9, and then the a factor is -1. So what this graph is going to look like is we're going to have a vertex at 0, 9, since it's translated up 9, and then it's just multiplied by -1, so it's concave down, like that. So I have y is equal to -3x squared minus 12x minus 3. And I want to put it in that form, so I'm going to factor out a -3 out of the first two terms. So I'll have x squared plus 4x. I'm going to complete the square on the inside of that, of the parentheses here. So I need x squared plus 4x. 4 divided by 2 squared is going to be 4. And if I'm adding 4 here, it's like I'm subtracting 12 total, so I need to add 12. So I have plus 3, and I'm going to have to add 12 to that. So I have the -3 factor here, and I'm adding 4 on the inside. To keep this whole line equal with the previous line, I'll have to do the opposite of what I did on the inside of the parentheses. And then I can contract this here. I'll have a -3 times x plus 2 squared, and then -3 plus 12 is going to be plus 9. Alright, so this is the form I was looking to get it in, completing the square. And I know that I have a factor of -3 that I'm going to be stretching the graph, and I'm going to be flipping it around so that it's concave down, not concave up. And it's going to be 3 times as steep. And I'm also going to translate it to the left 2 and up 9. So if I were to graph this equation really quick, if this was 1, 2 over and this was 9 up, then it would be much steeper than a normal parabola, so it might look something like this. So the vertex is at -2, 9, and it's concave down since it's multiplied by -a, and it's steeper than a normal parabola. And I could also go further, and I can find the zeros here. If I set y is equal to 0 and then solved for x, that would give me the 2 0 values there. So I think this is good for this video. So mainly I just wanted to point out that all quadratics are parabolic in shape, and the difference between all these different quadratics that you can come up with is how steep they are, or how compressed they are, and how they're translated into different areas of the Cartesian plane.